Hello everyone, it's great to have you all on board. It's another time with Tutorial, the teacher 624, and in today's tutorial, we are taking the course ECO 254 revision. Unfortunately, this particular course, we haven't done much justice to the classes. And basically, this is because we did not actually start early, but we are still, we've been able to give at least something. So on this, we'll be taking our revision class today. And for those of us who have not gotten the keynote of this course, let's ensure to request for the keynote of this course. And basically, the keynote is subdivided into two, the calculation part and the theoretical part, just like what we are going to be doing in today's class. We're going to be taking both classes. All right, we're going to be covering both classes, which is the calculation class and the theoretical class. But we all know how things have been done. We will cover the theoretical class first, then we will cover the calculation class next. So for those of us who are new to the stream, let's ensure to subscribe to the channel. Let's ensure to also turn on the notification bell, very important. And like I said earlier, come next semester, let's try our possible best to join the classes early. When we join the classes early, we can cover a lot together early without being under unnecessary duress. So to get the keynote, all you need to do is to reach out to us on our official website, which is tutorial, and you can use the WhatsApp button in the top right hand corner, send us a direct message, and we'll be happy to attend to you. And as well, this is the same route you have to use. You want to join the private class as well. And like I usually preach, the earlier we start, the better it is. Now, let's go straight into today's revision class. To start with, the theoretical part, I'm going to be taking a series of sub-objective questions as we go through things together. Okay? So the very first question we will be taking today is to define probability, right? To define probability distribution, you need to distinguish, all right, discrete and continuous random dash. You need to distinguish discrete and continuous random dash. Okay, You need to what? Distinguish discrete and continuous random dash. Awesome. Energy has been restored. So we have that as our first. Please let's keep the answers popping in. Okay, connect my device. So the charger, since the energy has been restored. So that's our first question. Please let's do out to provide an answer. And the earlier we do, the better we can get on with things. Is anybody happy with that? Okay, I need all hands on deck. Let's do out to use the comment section to provide answers to questions. This is the exam we're having tomorrow, for crying out loud. Let's do out to provide answers to questions. Very important. Okay, getting some nice responses already. Awesome, awesome. Yes, thank you very much for that. We all are doing a great job. Let's keep up with a good job. I need all hands on deck. Let's do how to provide answers to questions. Very important. Awesome, awesome. So we have that as variable. Yes, variables. Awesome. Now let's take the next question. Now it says, question 2. The random variable takes value from a dash probability. A random variable takes value from a dash probability. A random variable takes value from a dash probability. So we have question 2. Okay. Okay. Awesome. I think we are back now. All the things from the service provider. So we have a random variable take value from a dash probability. What's going on? Comment section is pretty dry. Are we not prepared for this exam? This exam is happening tomorrow, for crying out loud. I expect so much from us. Is Miss Candy on this stream? Awesome. Yes, we have continuous. Yes, we have continuous. Okay. Now let's take this. It says a discrete probability distribution is characterized by a probability dash function. A discrete probability distribution is characterized by a probability dash function. So we have that as our next question. Now we have that as that. A discrete probability distribution, all right, is characterized by a probability dash function. Awesome. Let's keep the answers popping in. Yes, thank you very much for that. We have that as mass. Now let's take the next question. It says for a continuous probability distribution, it has a probability dash function. Are we together? A continuous probability distribution is a probability distribution that has a probability dash function. Okay, has a probability dash function. That is for continuous. Awesome. Wonderful. Yes. Density. Let's keep the answers popping in. density. Awesome. Now let's see the next one. It says if the distribution of x is continuous, then x is called continuous dash variable. If the distribution of x is continuous, then x is called a continuous random dash. So we have that as that. If the distribution of x is a continuous, all right, a continuous, if the distribution of x is continuous, called a continuous random dash. Awesome. Thank you very much for that, Ms. Kendi. A continuous random variable. Awesome. Yes, awesome. I think it's better that way. Yeah. Let's take a couple of more questions before we move to the calculation part. Just like I said, for those of us who haven't gotten the keynote yet, Please ensure to request the keynote of the course after the class. How do you get to do that? All you need to do is to reach out to us through our official website, which is www.tutorial.net, and you can use the WhatsApp button in the top right hand corner to send us a direct message. Okay. Now, we have let's take this question. It says, the probabilities associated with individual values of x cannot be dash or greater than 1 since this has no meaning. The probabilities associated with individual values of x cannot be dash or greater than 1. Okay. Let's give the answers popping in. Also, I need all hands on deck. I need everybody on the stream to respond. Awesome. Yes, thank you very much, everyone. We all are doing a great job tonight. Now let's take this. It says the dash curve is one of the most popular models used in statistical tests of hypothesis. The dash curve is one of the most popular all right. One of the most popular model used in statistical tests of hypothesis. Okay. So we have data stat. Oh, wonderful. Thank you very much for that. Yes, we have that as a normal. Awesome. Now let's take this. It says a statistical test in which the critical area of a distribution is one-sided. In which one of the critical area of distribution is dash. Now, the complete sentence is a statistical test in which the critical area of distribution is one-sided, all right? So that it is either greater, all right, either greater than or less than a certain value, but not both, is known as dash, but we have abbreviated it because of space. I'm going to say that again. A statistical test in which the critical area of distribution is one-sided, all right, that is either greater than or less than certain value, but not both, is known as dash. Awesome. Yes, we have that as one tail test. One tail. Awesome. Thank you very much for that. For two tail, it is two-sided, unlike one tail that is one-sided. So please take note of that. For a non-directional dash, for a non-directional dash, a two-tail test is used when finding the critical region for a non-directional dash. Is used when finding. Okay. So we have that as that. I need all hands on deck. Awesome. Getting some nice responses. Awesome. Thank you very much for that. Hypothesis. Hypothesis. Let's keep the answers popping in. Awesome. Okay. Now let's take this question. It says the first procedure for carrying out hypothesis test is to dash the null hypothesis. The first step or the fourth procedure when testing okay, the first step okay, aha, I think it's better that way. Let's keep the answers popping in. Okay, can see some nice responses already. Let's keep the answers popping in. The first thing, when carrying out yes, thank you very much for that. Okay, yes, we all are doing a great job. Okay, yes, thank you very much for that. Let's keep the answers popping in. I need all hands on deck. Awesome. We have that as state. I think we've taken enough of theoretical question. Now let's to the other side as it takes some few questions on calculations as well. Okay, function, the function of x we have b raised to the power of 2 and we have 0. We have 0 less than x is less than 3. And here we have otherwise. So in a situation like this, mind you, I believe you are aware that the question might not be arranged the way I'm arranging it now in the class. It might come in a different format. But what you have to bear in mind is look out for the functions. All right? Look out for the functions. Are we together? So we are expected to find find p into brackets 1 less than x less than 2. Okay. Now, to find the first thing we're supposed to do in a situation like this is to first find the value of b. Okay? And by doing so, we are going to be using the density function. Now, we have we have 3 and we have 0. And we have bx raised to the power of 2. We also have dx equals to 1. Don't forget, we are looking for this, and this is here. Are we together? Now, we are getting started. Please write this down. I want to erase the board. What do we do? The function 3 and 0, all right? Remember, we have our x raised to the power of 2, all right? Let's write this formula out. There's a formula we have to apply. Let's write it here. 3 and 0. And we have bx raised to the power of 2. And we have dx equals to 1. Please let's write that out. Please, anything you don't understand, please draw my attention to it so I can guide you. So that is written out there. So we are bringing out what we have here. All right. We are reinterpreting it here, which is dx equals, open this now, and we have, since 3 is the function here, so we are using x raised to the power of 3 now, all over 3, close brackets, we have 3 here, and we have 0 here. All right. So from what we have here, we have these 3, all right, we bring it out here, and these 3 we have in here, and we have these 3 here, okay, minus this is 0. That should be giving us 27. When you calculate this, 3 raised to the power of 3 should be giving us 27. over 3. Please, what's the final answer? Awesome. Yes, thank you very much for that. Okay. Now, doesn't end there. Okay. The next thing we have to do now the next thing we have to do now, which is step 2, is to get the density function. Okay. And by getting the density function, we have to convert 9 into fraction. Don't forget that we were solving for this, the value of this, and we have been able to get 9, which is b, is equals to 1 over 9. Are we together? Now that we know what b is, then we can proceed. But before then, let's make a correction. All right, 1 over 9, no longer b. The next thing to do now is to find the cumulative distribution function. Okay. There's a formula we are going to be using to do that. And this formula is this is what we need now. I'll explain better, don't worry. So let's break it down. Same function we have. All right, x 0, t raised to the power of 2. Then we have dt that open to break brackets. Remember, we're using 3. All right. But we see about 3, and we have this here. We have our x, which we ended up with x raised to the power of 3 under 3. Now, the cumulative distribution function, therefore, all these basically are trying to interpret the formula. So now let's plug things in properly. All right. Considering what we're given, CDF, cumulative distribution function for 0, not less, not greater than, all right, 0 less than x and x less than 3. So what do we do now? We have function f into bracket x will give us 1/9. All right, multiply by the cumulative distribution function. All right, so with this we'll be having this x raised to the power 3 over 27 multiply. This is multiplication. Are we following? Okay. So now let's take this final step. Solving for so this will be modified. So this will be modified now. That's what I'm using to solve the last one. Okay. To find less than not equal to x less than not equal to 2. So we have function of 2 equals to 2 raised to the power of 3 over 27. Still the same thing as 8 over 27. And for function 1, all right, it's still the same thing as 1 over 27. So we have that as that. So like I said earlier, there is a well-written and structured calculation for the course. Like I said, there's a theory, there's a calculation part to the course. So if you have not gotten the calculation, but you have gotten the theory, or you have not gotten none, please reach out to me on our official website and request. So you can go through them yourself and also spend some time digesting them. I wish you all the best and success in your exams tomorrow. Like I said earlier, let's ensure to join early next semester so we can take classes without being under unnecessary pressure. Have a wonderful evening and bye for now.